All right, do you guys see the slides?
Yep.
All right, cool. Yeah, so this talk is going to be about preventing silent failures, and one of the tools that Python has available to help with that. In my experience, I found that silent failures are the worst kind, because instead of raising some kind of error and stopping execution, the code continues on to do the wrong thing or to do nothing when it should have done something. And sometimes you will end up discovering this downstream when something is broken or missing. And sometimes you're missing backups, or there's data corruption that you don't even detect until far too late. In general, I find that the best thing to do is to fail as early as possible, partly because you don't want the downstream consequences to be worse, and it's very hard to predict what they're going to be, but also partly because it means less has happened. If it continues past the failure, then everything that happens from that point until detection is a possible cause, and you have to eliminate all those things as you trace back through and try and diagnose it. So I try to pull failures as early in the execution process as possible and make them actually stop execution. And the Python language is really designed to work this way. This is a quote from PEP 20. We're up to PEP like 400 or 500 now. This is one of the first that was written. Errors should never pass silently. The language, and I hope most of its ecosystem, is really built on the assumption that when something goes wrong, there's going to be an exception that's going to stop execution and print some kind of stack trace that tells people what happened, so it can be diagnosed. So to give one example of a category of silent failure that I run into all the time and how assert statements can help deal with that, I'm going to use this kind of laboratory AWS infrastructure that has EBS volumes. Those are just virtual disks, and a little snapshot backup script that's written in Boto 3, which is the SDK for Amazon's API. This is just a demo script. Obviously, there's things wrong with this. You wouldn't actually use a script exactly like this in production, but it's enough to show the category of error. So all this script does is filter out volumes in the system that are named awesome stuff and run a snapshot of them. The problem is this line. So like most filters or searches, it's going to return its results in an iterable, and I end up with this list of everything that it found. And so what I did was I just kept writing a more and more precise filter until I got the one thing I was looking for, the volume named awesome stuff, but that's still in a list. So I have to get that out of the list. And so I just pull the first element and then I make a snapshot of it. The problem is that multiple volumes could actually match this pattern. You could have two different volumes with the same tag on them, which ultimately means that this line encodes two different assumptions. The first one isn't too bad. It is that there is at least one such volume. If there's not, the list will be empty. We'll get an error when we try to pull the 0th item out. And so we'll know something went wrong and we can deal with it. That's okay, it failed right away. The second assumption is that there isn't more than one volume. And that's the tricky one, because if there is more than one, it's going to pick the first one and only that volume will get a snapshot. So the problem is we, of course, don't know if that was the right awesome stuff volume. If somebody had, for example, made some copies of this volume for testing, and then for whatever reason, one of the volumes that's not actually in use ends up sorting first in that list, that not in use volume is going to get backed up over and over and over again happily. The logs are going to say everything is fine, but the volume that actually has new data streaming into it will not be getting backed up, and you may not notice that until that volume gets deleted accidentally somehow. And then all of a sudden, all that data is gone and it's unrecoverable because your backups weren't covering it. And the worst of it is that this manual action, or that's just one example of how that could happen. That situation could arise from other causes. But the point is that the code wouldn't have to change for that to happen. A state change in the system behind this API would be enough to cause this script to back up the wrong thing and never tell anybody. So I don't want that to happen. I want this script to fail if its filter doesn't detect exactly what I expect it to. For categories of errors or of code like this, what I tend to do is just put one assert line. And all this thing is going to do is raise an assertion error, an exception, if the condition that it defines is false. So if that list of volumes is not exactly one, then we're going to get a traceback like this. It throws an assertion error, prints out the line that had the problem on it, bails out, the script will stop, somebody knows they need to do something. You can add custom error messages if you need to. For things like this, I usually don't, because I personally find this traceback to be pretty readable, but you can add more verbose messages if you need that. So the way I've solved this using an assert doesn't remove the assumptions. The code still has both the two assumptions we looked at, but that's fine because it also checks that they're true before those assumptions are encoded. There are other ways that I could have solved this problem. I could have made the script more robust so that it could handle multiple volumes if there are multiple volumes there, and back them all up, or maybe send somebody an email or whatever if there are more than expected. But I tend to take the simplest approach. If for whatever architectural reason, I know that there should only be one volume and that there should be at least one, there should be exactly one, then the simplest thing for me to do is just write the script to find that volume and back it up. And then I just need this fallback to make sure that if that state ever isn't what I expected it to be, I get some kind of an error so that I know that I either have volumes sitting around that should be removed, or that I need to make the script more robust to handle more volumes because the system has grown or whatever. This assert line is a quick one-liner. You can scatter this all over your code. And as long as the situation is what you expected it to be, these will never cause a problem. They don't add verbosity to the logs or anything, but they do protect you if the situation expands or changes beyond what you thought that it was going to be. So the best practice that I try to follow whenever I'm writing any code, but especially code that consumes APIs like this, is that it's okay for my code to have assumptions, but when it does, I assert that they're true, so I get clear failure messages whenever they're not. And that's all I got. I'll open it up for questions now if anybody has any.